joint variation, our third example under our third type under variation, we are there with direct variation and inverse variation or indirect variation. We are moving on to joint variation. So we are going to join them. This is a variation where two or more quantity being related to each other. So where we have two or more quantity being related to each other is a joint variation. So we have a typical example of the formula for the volume of a cone. Yes, the volume of a cone is related to the radius and the height. Okay, so what's the formula for the volume of a cone under mensuration? Good. So this is the formula. Yes. So you see, the volume is being related to the R and H. So the type of variation, type of joint variation. So it can be, the variation is direct for all the variables. Okay, so all can be direct, and it can be direct and inverse. All can be inverse. Okay, it depends on the question. Okay, so now you know how what direct variation is, inverse variation is. We can do with the joint variation. Okay, so this is our first type. So I have an example here. The variable z varies directly as s and directly as y. So how do you write z? The variable z varies directly as s. We know how to write that one, the mathematical expression, okay? And directly as y, okay? Don't say n, that's why you're going to bring n. So this is the mathematical form, okay? So the z varies directly as s and y. Z varies directly as S and Y. Okay, so that's all. The variable Z varies directly as S and directly as Y. And this is what they mean. It can be the variable Z vary directly as S and Y. They are the same. Okay, so Z vary directly as S, Z vary directly as Y, and this can be written as this. Good. So then let's put an equation form. That's where you introduce the k, right? Yes. Good. So where k is constant proportionality is here. Where k is constant proportionality. Good. So that's the equation form. Then my second type of joint variation is the variation is inverse for all the variables. So this was direct. All of them are direct, okay? And this one was inverse for all the variables. So I'll have example here. So all can be inverse. And we want to know how inverse variation is. The variable z varies inversely as s and inversely as y. So the mathematical expression here. So here was z varies directly as s, okay, and z vary directly as what? Y. Okay, and this can be written as z varies directly as what? S and what? Y. That's what is there. That's what it means. Okay, good. Then here, let's go. It means that z varies inversely as s. And what's inverse? We talk about it, one out of what? S. Okay, and so z varies inversely as y. So it's like z varies inversely as what? Y. So let's join them. That's what we say it's a joint variation. So it becomes z varies inversely as this s and what? Y. Are we good? So this is what they mean. So that's what is here. Good. So z varies inversely as s and inversely as y. It can be written as z varies inversely as s and y. Yeah. Okay, so let's put this one in an equation form where we introduce the k. So it will be what? Yes, so this is an equation form, nicely. Then last one, let me clean the rough rec, our board. Last one, the variation is the combination of direct and inverse variation. So it can be inverse and direct. They can combine the two of them, okay? So under joint variation, we are saying that it can be all direct, all inverse, and not both direct and not inverse. I have example here. Z varies directly as X and inversely as Y. So Z varies directly as what? S. Okay. Then let's pause here. Z varies inversely as Y. Okay. So the combination of this. So you have Z here. So it varies. So here it varies directly as S and inversely, because this one become what? 1 on Y. Okay. So that's what. And inversely as what? Y. So it becomes Z varies directly as S and inversely as Y. Okay. Nicely as this. Okay. So let's know how to write these variations. It's very easy. Good. So let's see our final. So that's what? Z varies directly as S and inversely as Y. And let's put in an equation form where we introduce the K, where K is the constant proportionality. Okay, so this is what we mean under joint variation. So now that we know how to do for joint variation, we can express this in mathematical form. Let's solve example under joint variation. Our first example under joint variation. So this is a joint variation. I1. Wow. So this is the question. So solution. Now, from the question, S varies jointly as the square of M and the cube of N. So S varies as jointly as the square of M and the cube of N. So this combination of what? Yes, they are all direct. So there's no direct here, but they are all direct. S varies jointly as S, the square of M and the cube of what? N. So here, it's like this. So S varies, the vary sign, jointly as the square of M, so M square, and the cube of what? N, so cube of N. This is what they mean. Okay, good. So this is what they mean. It's here. So let me clean about. That's what it means here. Okay, so these are all direct. Okay, so there's no direct here, but you have to know S varies jointly as the square of M and the cube of N. So you are given when S equals 9, M equals 3 on 4, N equals 1 on 2. We are given this, and this we are given will help us to find what the K. So let's put this one into an equation form where we introduce the K, where the K is the constant proportionality. Good. So we introduce the K, so the equation form. So you see, this one is involved in 3 variables: 1, 2, 3. That's why we're given 3 here. 1, 2, 3. So we're given this in the question. So just substitute this one into the equation 1 to find the K as we are solving for the previous direct and inverse. So let's do substitution because S is 9, K is 3 on 4, which is here. M is 3 on 4, which is here, and what? N is 1 on 2. You just do the substitution, then you solve. So square being affected by 3 and 4, we are done with indices. So if you have not watched the indices video, go back and watch it, please. Okay, so you just square here and square here, keep here and keep here. So you get this. 9 equals, the square of 3 is 9, the square of 4 is 16, the cube of 1 is still 1, the cube of 2 is 8. Good. So now you can just multiply. 9 times 1 is 9, 16 times 8 is 128. So if you multiply 2, you get this. Okay. We are solving for k. There's a denominator here. Always remove the denominator so that it becomes a linear expression. So let's multiply both sides by 128. Multiply both sides by 128 here. 1, 2, 8. Then here 2 by 1, 2, 8. Okay, we always do this. Then 9 times 128 will give us what? 1152. I think so. So good. That's why I have this. So 9k equals 1152 because you just multiply by what side. Then want k, divide both sides by 9 so that you can get k. Therefore your k is 128. 128. Divide both sides by your k. Good. So I determine the relation between S, M, and N. So let's determine the relation between the S and N, which is this. So what they are saying, determine the relation between S and N. So now we know the K, so you just substitute this one into the equation in here. The equation 1, then you find what? Okay, that's the new K. For the II, A, calculate correct with 3 significant figure the value of S when M equals 3, 2 on 3 and N equals 1 on 5. Good. So S equals 1 on 5. So we are given from the equation, we should find the A. So now that we know the K, this is our new equation. We have to find S. So we are giving M and N. Just do the substitution. Then you solve. So this one, you can solve it straightly, or you can use your calculator to solve it. So when you solve this, you get S equals 0.455. They say 3 significant figure. So we have what? 0 is here. So we start from 1, 2, 3. That's why we have 0.455. I know you know how to solve for significant figures. Then B, we should calculate for M when S equals 5, M equals 1 on 8. This one you can solve it, and give me the answer. So now you know your equation here. So you have to find M. Okay, so just make M the subject. You then substitute. Good. Then you solve for M. Let's solve for M. You can solve it very easily. So this one, 1 square is still 1. Then 8 square, 8 cube, 1 cube, and 8 cube. You get your answer. Then you move the denominator. Okay. Good. Okay. So 8 cube, then this one goes here. Then you have this. Therefore, your M is this. Your M is this. So the problem of variation, you have to know how to write the equations, okay? The mathematical expression before knowing the equation. So this is our first example under the variation. So our second example on the joint variation. Solution. So from the question, Z varies directly as s and inversely as twice the key root of y. Wow. So you have to know this mathematical expression in here for variation. So z, let me try to do something here. Z varies directly as s and inverse as twice the key root. So the key root is written as this 3 here of y. So let me do bracket here, okay. And this can be written as z varies directly as s times 1 is still s. Okay, so this can be written as twice the key root of what? Y. Okay, y. And key root, do you know that you have done indices? So okay, key root of y can be written as what? This, right? So anyway, you can read the key root as this 1 on 3. Good. So let's see. Yes, that's what they are saying. 9-3. So that's what z varies directly as s and twice the key root of y. Nice. So let's form our equation where we introduce the k to remove the vary sign. Good. Where k is the constant proportionality. So then we're given this in the question. Yes, so you just do the substitution. Substitute this one into the equation 1 to find k, because they are not asking you to find k, but substitute you find k. Okay, good. That's very nice of you. So just the substitution in there. Z is 8, S is 4, K is this. So the cube root of 1 on 8, the cube root of 1 is 1, the cube root of 8 is 2. So this can be written as this. Yes, the cube root of 1 on 8 is 1 on 2. Then these 2 will cancel these 2, because 2 times half is still what? Half, so it will cancel. This one will go and this one will go, okay? So therefore, it becomes 8 equals k. That's all for k. So let's divide both sides by 4. Divide both sides by 4. So that it will cancel. 4 goes here 2. So therefore our k is what? Our k is 2. Nice. Let me clean my board nicely. Good. Find the relation for y in terms of m and n. So let's put this one into the equation. K is 2. Put this into the equation 1. So here k is 2. So from equation 1, the k is 2. And this is what they are saying. This final answer, no, there's 2 here. So this 2 will go. So there's 2 here. There's 2 here if you simplify. Therefore, our final answer is this. Okay, they say you should find a relation of y in terms of m and s. It's not find a relation of z in terms of s and y. They say you should find the relation of y in terms of s, find a relation of y in terms of s and z. Okay, good. So this is a relation. Let's make y the subject. Yes, can written as this. This can written as this, because this will go, this will come. Or you just multiply both sides by the denominator, then divide both sides by the z. You get this. We are making the y the subject. From the question, we want the relation of y in terms of s and z. So you just, there's a key here. So let's key both sides. Let's key both sides. Okay. You can know that the key root, talk about this. Okay, and indices, the key root of y can be written as y 1 on what? 3. Okay, so when you take cube of both sides, when you take 3 on both sides, it will cancel. This and this will cancel. That's what is here. So you get y. Okay, so this can be written as 1 on 3 times the 3 here. So it will cancel. Okay, very nice. Good. So we take cube of both sides so that we remove the cube roots. Then we have this. And this is what they are saying. Find a relation for y in terms of s and z. S and z. That's our second example. Let's move on to our third example under joint variation. Third example under joint variation. Nice. Solution. S varies directly as the cube of y and inversely as the square root of z. Let's see this expression. So S, let's write it here. S varies directly as the cube of y. So how do I write the cube of y? This. And inverse as the square root of z. So square root of z is the square root, my 9 square root. Oh, okay, nice. So that's what they are saying. So learn how to write this. Good. Then you put this one into an equation form. Okay, you put this one into an equation form. So this was the expression. The equation helps us to solve it. Where you introduce the k, the constant proportionality. In the question, if s is 108, y is 3, z is 4, so s is this. Then let's put this one into equation 1 so that to help us to know the row equation. Okay, so get the substitution in there. 3 cube is 27, then 4 is 2. So this can be written as this. So we have to solve for the k, multiply both sides by 2. You get this expression. For 2 times 108, you get what? 216. Then want k, then divide both sides by 27. Then your k is 8. Very simple. Now that we know k, put this one into the equation 1. Yes, this is our equation. Our new equation here. Now, find z when s is 4000, y is 10. So it says we should find z when s is 4000, y is 10. So substitute this one into your new equation. Yes, your new equation. We should make z the subject, multiply both sides by root of z. Then divide it by 400. So just make z the subject. Okay, you just make z the subject. So multiply both sides by root of z, here by square root of z. So this and this will go. Good. Then you want z to stand alone, so then you divide both sides by the 4000. So here to be what? 4000. Okay, so that this will go. So you see, you'll get this. Good. Then this is what I was saying. Nicely. Okay. Yeah. So this 10k results. That's 10,000 times 8. You get what? 8,000. They make this the subject. That's what I was doing. So you get what? Root of z out of this. You want to make z the subject. This 0 will cancel. So you get what? 4 goes to 8 is 2. You get z equals 2. Root of z, square root of z equals 2. So I want to find the z. So I have to square both sides so that the square root will go. Then your Z is 4. Very simple. Very simple. So that's for the joint variation. Our next one will be on the partial variation. Subscribe to Senior Fellows, my YouTube channel, for more videos. Give it a like. You can share it to your colleagues. Okay? Bye bye. Watch out for the partial variation.